Good day, grade 11 students. Welcome once again to our general mathematics class. I am Mr. Clifford G. Estrellado. In my previous video lessons, I discussed about concepts of functions and evaluation of functions, including the piecewise functions, the operations on functions, and solving real-life problems involving functions. Today, we will start our discussion on chapter 2. So we have lessons 1 and 2 about rational functions, equations and inequalities, and representations of rational functions. So objectives for our lesson. At the end of this lesson, you must be able to distinguish rational function, rational equation, and rational inequality, and represent real-life situations using rational functions by means of table of values, graphs, and equations. So let us start. Rational functions, equations, and inequalities. So what is a rational expression? When you say rational expression, it is an expression that can be written as a ratio of two polynomials. So it means that the numerator and the denominator must be polynomials. So let us have this activity. Identify whether the following algebraic expression is rational or not. Again, take note, when we say rational expression, both the numerator and the denominator must be polynomials. So let us recall, if you can remember what you have discussed when you were in junior high school about polynomials. So we have x squared plus 3x plus 2 over x plus 4. Is it a rational expression or not? So I'll give you 3 seconds to think. Okay, let us check your answer. It is a rational algebraic expression. So the numerator is 0 degree polynomial and the denominator is on the first degree polynomial. Next. How about 1 over 3x squared? Is it a rational expression or not? Okay, it is a rational algebraic expression. So 1 can be written as 1x raised to the 0 power. So a 0 degree polynomial. And the denominator is on the second degree polynomial. Next. About x squared plus 4x minus 3 over 2. Okay, very good. It is also a rational algebraic expression. Numerator is on the second degree polynomial. The denominator is a 0 degree polynomial. Next. About square root of x plus 1 over x cubed minus 1. Okay? So this is an example of not a rational algebraic expression. Why? So square root of x plus 1 is a radical expression and we can rewrite that as quantity x plus 1 raised to 1/2. So we have a fractional exponent. And if we have a fractional exponent, so that is not a polynomial. Since our numerator is not a polynomial, therefore, it is not a rational algebraic expression. Okay? While the denominator x cubed minus 1 is a polynomial. Next. We have x raised to negative 2 plus 4x minus 3 divided by 2. Or x raised to negative 2 plus 4x minus 3 over 2. Okay? It is not a rational algebraic expression. Why? Because on our numerator, so the first term has an exponent of negative 2. And it denotes that the numerator is not a polynomial. Because when we say polynomial, the exponent must be a whole number. When we say whole number, so it is 0, 1, 2, 3, 4, so on and so forth. Okay? So meaning, it is not a polynomial if the exponent is a negative number or if it is a fraction or decimal. So we cannot consider that as polynomial. Okay? So rational function. It is a function of the form f of x is equal to g of x over h of x, where g of x and h of x are polynomial functions, and h of x should not be equal to 0. Because if h of x is equal to 0, then we will have an undefined function or a meaningless function. If g of x over h of x is equated to 0, then we have g of x over h of x is equal to 0. And it is called a rational equation. Moreover, if the equation symbol equal is replaced with less than or equal, greater than or equal, you have a rational inequality. Let us have this activity. Identify whether the given is a rational function, a rational equation, or a rational inequality. Again, you have 3 minutes to think. So we have 2 over x minus 3 over 2x is equal to 1/5. Is it a rational function, a rational equation, or a rational inequality? Okay? So, it is a rational equation. Okay? On the left side of the equation, we have rational expressions, and on the right, we also have a rational expression. Okay? Next, about this one. 5 over x minus 3 is less than or equal to 2 over x. Okay, it is a rational inequality because of the symbol that we have less than or equal. So on the left side of the inequality, we have 5 over x minus 3, so it is a rational expression. And on the right side of our inequality, we have 2 over x, which is also a rational expression. Next, about this one, we have f of x is equal to x squared plus 2x plus 3 over x plus 1. Okay, we have a rational function. Okay, f of x, the name of our function, and on the right side, we have x squared plus 2x plus 3 over x plus 1, wherein it is a rational expression. Next. So here is a summary of rational equation, rational inequality, and rational function. You say rational equation, again, it is an equation involving rational expression. So, example, x plus 4 over x minus 1 is equal to 1/5. Rational inequality, an inequality involving rational expressions. So, example, you have x minus 2 over 5 is greater than 3. And rational function, a function of the form f of x is equal to p of x over q of x, where p of x and q of x are polynomial functions, and q of x is not the 0 function. So example, we have f of x is equal to x squared plus 6x plus 8 over x plus 4. Next is the representations of rational functions. Some real-world problems can be modeled using rational functions. And we can represent rational functions by means of table of values, equation, and graph. Let us have here an example. The local barangay received a budget of 100,000 pesos to provide medical checkups for the children in the barangay. The amount is to be allotted equally among all the children in the barangay. Write an equation representing the relationship of the allotted amount per child versus the total number of children. Make a table of values and sketch the graph. Okay, so let f of x be equal to the allotted amount per child, and x is equal to the total number of children. So we have now this rational function. F of x is equal to 100,000 over x. So our problem is represented by means of an equation. And we have an equation, f of x is equal to 100,000 over x. Another way of representing rational function is by means of table of values. So by means of table of values, if the number of children is 50, so the allocated amount, by using the equation that we have, f of x is equal to 100,000 over x. So 100,000 divided by 50 is 2,000 pesos. If the number of children is 100, so meaning x is equal to 100, so using our equation, f of x is equal to 100,000 divided by 100, so we have 1,000 pesos as the allocated amount. If the number of children is 200 pesos, okay, so we have f of x is equal to 100,000 divided by 200, so we have an allocated amount of 500 pesos. If x is equal to 300, there are 300 children, so f of x is equal to 100,000 divided by 300, so we have 333 pesos and 33 centavos. If the number of children is 500, so we have f of x is equal to 100,000 divided by 500, so meaning each child will receive 200 pesos from the barangay. If the number of children is 1,000, so we have 100,000 divided by 1,000, so meaning each child will receive an amount of 100 pesos from the barangay. Okay? So again, we can represent rational functions by means of an equation, by means of a table of values, and by means of a graph. So if we will graph the values on our table of values, so we will have this kind of graph. And that is a graph of our rational functions. It is a smooth curve. Okay? So that's all for today. Let me end my discussion with this Bible verse. Cast all your anxiety on Him because He cares for you. That is according to 1 Peter chapter 5 verse 7. So thank you so much for watching. God bless all of you. Goodbye.